You are listening to The Vocal Technologist. Spoken tech for your ears.
If you work anywhere near modern software delivery, you know the feeling. You just get comfortable with your cluster setup, and then boom, the entire ground shifts beneath your feet. I mean, the speed of change in the DevOps space right now isn't just fast, it's a complete architectural overhaul. We're watching organizations trying these massive cost-saving plays on infrastructure, while at the same time rolling out AI agents that write and deploy code. It's a wonderful, frenetic time to be paying attention.
It really is. And what's so fascinating is that it's like two parallel revolutions happening at once.
Exactly.
You've got the foundation itself being optimized right down to the kernel level, just as the entire automation layer on top is being handed over to these intelligent agents.
So that's what we need to unpack today.
Yeah, our mission is really to distill those two shifts. We have to look at these foundational, networking efficiencies right alongside this explosion in AI-driven developer tools.
And how they interact.
Understanding how they interact is absolutely essential if you want to stay ahead of the curve.
Okay, let's start exactly there, at the foundation. The big theme for infrastructure right now seems to be just radical efficiency. We're talking about optimizing for milliseconds and maximizing every dollar.
And you can't get more fundamental than the network stack in a Linux environment.
Absolutely not. The big news we saw came from Calico with their v3.31 release. The headline is that NF Tables is finally moving to general availability.
Oh, yeah.
For anyone who isn't, staring at kernel changelogs all day, this is a major performance upgrade. NF Tables promises some really significant efficiency gains over the old IP tables.
It just streamlines everything within the kernel.
Right. And that efficiency, it pays dividends across the entire cluster. It's not just that NF Tables is better at high-volume rule processing. Calico also made a huge architectural simplification here.
They did.
Tell us about that simplification, because I think the impact of this detail is often overlooked.
Well, the new default installation template now uses the high-performance eBPF data plane. And here's the kicker. Doing that lets Calico automatically disable kubeproxy entirely. That is huge for simplifying the cluster and boosting raw speed.
Wait, let's just pause on that for a second. Disabling kubeproxy. Why is removing that component such a game changer?
Because kubeproxy usually is in user space, and it handles service routing by inserting firewall rules, which can be a massive performance bottleneck.
Especially in big clusters.
Especially in big clusters. When you move to an eBPF data plane, you're pushing all that packet handling and service routing into the kernel space itself. It's just vastly more efficient, faster, and it reduces latency.
Okay, so that's the technical performance boost. Now let's connect that directly to financial performance, because it feels like organizations are taking these efficiency gains and running straight to the bank.
They are. We're seeing this massive trend toward escaping cloud lock-in, or at the very least, really, really optimizing cloud spend.
Take Nanit. Great case study. They manage short-lived video uploads from baby monitors. That data used to all go directly to Amazon S3.
Right, but they realized that most of that data has a very short lifespan before it just gets deleted.
So they built their own thing, N3, built in Rust of all things.
Precisely. N3 is this custom in-memory system that acts as the primary landing zone for the data. They only offload the overflow traffic, the small percentage that lasts longer, to S3.
And the savings.
By making that one architectural switch, they estimate they're saving about $500,000 a year in S3 fees.
$500,000. That is incredible. But, okay, let's look at the grand escape. One Uptime published their analysis 2 years after moving completely off AWS and onto bare metal.
This is where we really need to connect the dots on cloud exit strategies, and One Uptime's results are, well, they're incredibly compelling.
I saw the numbers, annual savings exceeding $1.2 million.
Which was a 76% cost reduction compared to their AWS bills. And they did this running on self-managed Kubernetes and Ceph, and get this, their technical metrics actually improved.
Better availability and lower latency.
Yep. 99.993% availability and latency cut by 19%.
That 1.2 million is a colossal number, but let's be critical for a second. When you go bare metal, you don't just eliminate a bill, you acquire a massive operational burden, right?
Absolutely.
What about the CapEx, the expertise for self-managing Ceph, the internal talent? They saved 1.2 million, but what did they spend to get there?
And that's the crucial trade-off. It is a highly complex move that requires specialized infrastructure talent. You're basically trading that easy horizontal scaling for deep architectural control.
But for the right workload.
But for organizations with predictable high-volume workloads, One uptime proves the financial payoff can just far outweigh that initial investment. If your business needs max performance at minimal ongoing cost, managing the metal can still be the winning play.
Which means the decision isn't always to just ditch the cloud, but to use it wisely. We also saw some guides on how to hybridize intelligently.
Exactly. Sometimes you need the cloud control plane, but you need to run specific workloads externally, maybe for compliance or for super low latency edge compute.
That's where extending Amazon EKS with hybrid nodes comes in. But how do you secure those external nodes without creating a total security mess?
They securely fold those external Linux servers right into the EKS cluster using AWS IAM roles anywhere and HashiCorp Vault PKI.
Oh, okay.
It lets the external node authenticate securely and participate in the Kubernetes control plane without all this complex manual credential management.
Yeah.
It's leveraging the cloud for orchestration while you choose your own execution environment securely.
Okay, that brings us from optimizing the metal to automating the work that runs on it. And this is where the tech landscape just shifts into warp drive. The AI agent revolution. Developers are not just using Copilot to finish a line of code anymore. They're becoming conductors of, like, small autonomous AI teams.
This is the most profound acceleration we've seen in productivity. We're moving beyond assistance and into full-on delegation. AI agents performing entire development tasks.
From feature requests all the way to vulnerability patching.
All of it.
And the first step in delegation is always having a mission control. That seems to be where GitHub's new Agent HQ comes in.
Agent HQ is basically the central orchestrator. It's an open ecosystem that pulls together coding agents from all the major AI companies, all accessible through a paid Copilot subscription.
And it integrates into existing workflows.
Deeply. VS Code, Slack, Linear, it makes it the one place to manage these digital employees.
But of course, every time we talk about autonomous agents, the first concern is governance. If these agents are accessing our code base, how do we make sure they're secure?
That's the critical guardrail, and that's where the Model Context Protocol, or MCP, is stepping up. Docker's MCP Toolkit lets organizations build their own custom catalogs.
Explain that. What does an MCP catalog actually do?
Think of it like a carefully curated sandbox. It hosts over 220 containerized servers, and organizations use it to strictly control which AI tools or models their developers or their agents can access.
So it's about controlling the context.
Exactly. It ensures the AI isn't wandering into unauthorized data lakes or trying to run code in an unsafe environment.
And when you have those guardrails in place, the productivity is just astonishing. OpenAI introduced Aardvark, fantastic name, by the way,
Love the name.
their autonomous security researcher.
Aardvark is a GPT-5-powered agent designed for continuous security work. What's so wild is that it continuously scans, validates, and then patches vulnerabilities. It uses LLM reasoning to understand the code, runs sandboxed exploit tests, and then proposes fixes.
And the results?
In benchmark tests, it hit a 92% recall. It autonomously found and fixed almost all of the security issues they injected.
A 92% recall autonomous security team member is a huge step forward. That kind of automation leads directly into this idea of structured vibe coding. You have to unpack that term for us. It sounds like jargon someone just invented.
It does, but it's really just formalized delegation. You
Right.
can't just let the agents run wild. That would be chaos.
Right.
Structured vibe coding is about treating the AI agents like highly efficient but very structured team members. You guide them with clear, spec-driven development. The vibe is that structured environment you provide.
Yeah. So instead of asking Copilot to write one function, I'm giving an agent a full spec sheet and saying, implement this feature and write the tests for it, but with strict human oversight.
Exactly. It automates the repetitive stuff, but still requires clear human management. It's the framework for getting scale and reliability with AI.
Okay, that brings us back to the reality of the everyday developer experience, because even with all these agents, core tool performance still matters a lot. We have to talk about Python's new GameChanger.uv.
UV. If you're a Python developer, you are probably already nodding your head right now.
I definitely am.
It's a Rust-based Python management tool that handles dependency resolution, installation, everything. And people are calling it the most significant improvement to the Python ecosystem in a decade.
And it solves such a massive pain point. If you've ever waited 15 minutes for pip to resolve a complex environment, you know that pain.
That's right. UV is just ridiculously fast.
Yeah.
Because it's written in Rust, it has this unmatched speed and consistency. Where pip might churn for minutes, UV is often done in seconds.
It's revolutionary for just spinning up new environments.
Absolutely. And that need for velocity is also being sought in CI/CD pipelines. We saw updates from GitLab on parent-child pipelines.
Which is all about breaking down those monolithic, hard-to-manage beasts.
Exactly. It lets you break down massive CI/CD processes into smaller, self-contained pipelines, much easier to orchestrate and debug.
And they made sure the communication between them is seamless.
Oh yeah, sharing variables and artifacts is simple. It's all about making complex deployments readable and maintainable again.
Okay, finally, we need to connect all this speed and efficiency back to the ultimate goal, which is resilience and stability. All the optimization in the world means nothing if your system falls over.
Very true.
I found this new data-driven framework for measuring internet resilience fascinating.
This is so critical for assessing true stability. It uses public data to quantify a network's ability to withstand major disruptions. It goes way beyond simple uptime monitoring.
So what are the key metrics?
It looks at the diversity of routing paths, peering participation rates, and network hygiene checks like RPKI and BCP38.
Can you define those hygiene checks quickly? They sound pretty specialized.
Sure. RPKI basically makes sure network routing info is cryptographically verified, so it prevents hijacks. And BCP38 is about filtering out junk or spoofed traffic. Measuring how well a network adheres to these gives you an objective score of its resilience.
And that resilience is constantly under threat. Fastly's September report was a stark reminder of how DDoS attacks are escalating.
The intensity is hitting truly frightening new peaks. That report highlighted a record-breaking Layer 7 attack that hit 15.5 million requests per second.
For over an hour.
For over an hour against a media company. As we build these leaner, faster systems, the need for proactive protection against these massive attacks just grows exponentially.
So what does this all mean for you, the listener? If we step back and look at everything, from the kernel all the way to the agents, we've covered a profound transformation today on the Vocal Technologist.
We really have. We've seen organizations drilling down to optimize the underlying kernel with NF tables and eBPF, pursuing massive cost savings by moving off the cloud, and at the same time automating the entire development lifecycle with these incredibly intelligent agents.
And these aren't just small incremental updates. They represent entirely new paradigms for engineering, for compliance, for cost control. The future of operations isn't just automated, it's intelligent and aggressively optimized across the entire stack.
Which leaves us with a question. If organizations can prove they save $1.2 million by moving off the cloud, and these specialized AI agents can fix code with 92% recall, what's the next layer of the stack that we're going to choose to self-manage or fully automate? You have to constantly think about that delicate balance between operational complexity and monumental cost savings as these new tools continue to mature.
Spoken Tech for your ears.